Quantum Zeno Effect. Have you ever tried to watch a pot of water, waiting for it to boil, and it feels like it takes forever? You stare, you wait, nothing. The moment you turn your back, that's when you hear the furious bubbling. It's a classic kitchen phenomenon. But what if I told you this isn't just impatience? What if, on a fundamental level, your act of watching was actually preventing the water from boiling? Welcome, everyone. Today, we are diving into one of the most profound, almost magical secrets of our universe. A principle so powerful, it suggests that reality itself is not a solid, fixed thing, but a shimmering, fluid possibility. And that our simple act of observation can shape it, freeze it, and even stop time itself. This is the story of the Quantum Zeno Effect. To understand this, we need to enter the bizarre world of the quantum. This is the realm of the impossibly small, atoms, electrons, and photons. And down here, the rules are nothing like what we experience. Down here, particles don't just exist in one place, they exist in a blur of all possible places at once. This is called a superposition. An atom can be both here and there, spinning up and spinning down simultaneously. It's not until we look at it, until we measure it, that it's forced to make up its mind and settle into a single, definite state. Think of a quantum particle as a cosmic coin, spinning in the air. While it's spinning, it is neither heads nor tails. It is a probability cloud, a potential of both outcomes. This is its natural, restless state. Now let's say this quantum coin is unstable. It has a tendency to decay, to flip from this spinning state and land on, say, tails. It has a certain probability of doing this within a given second. Left to its own devices, it will eventually decay. But here is where the magic begins. What if, just a fraction of a second after it starts spinning, we take a peek? We make a measurement. What happens? Our look collapses the probability. The coin is forced to choose. It becomes heads or tails for that instant. But the moment we stop looking, it immediately goes back to being a spinning coin of potential. And the decay clock resets. Now, what if we become obsessive? What if we don't just look once? What if we stare? We measure it again and again and again in rapid, relentless succession. Every single time the particle tries to start its journey towards decay, we interrupt it with a question. Are you there? And every single time it has to stop, answer, and reset its internal clock. If we do this fast enough, something incredible happens. The particle never gets the chance to decay. It is forever frozen in its initial, unstable state, trapped by the relentless gaze of observation. This is the Quantum Zeno Effect, named after Zeno of Elea, an ancient Greek philosopher who proposed paradoxes about motion, like an arrow never reaching its target because it must first travel half the distance, then half of the remaining distance, and so on forever. In the quantum world, our observation creates a similar paradox. By constantly asking, "What are you?" we prevent the particle from ever becoming what it was destined to be. Let's leave the lab for a moment and think about this in a way that might send a shiver down your spine. What is reality for you? This desk? This screen? Your own hands? We perceive them as solid, stable, and continuous. But what if, at the very foundation, this stability is an illusion? What if the universe is fundamentally unstable, a constant, frantic dance of probabilities, and the only reason it appears solid is because it is being constantly observed? Think of a fluorescent light. It appears to emit a steady glow, but in truth, it's flickering on and off so rapidly that our eyes perceive it as continuous. Now, imagine the fabric of reality is like that. What we call a static object is, at the quantum level, a storm of events flickering in and out of existence. The Quantum Zeno Effect suggests that the collective observation of the universe, perhaps by us, perhaps by something else, acts like a rapid-fire strobe, light of attention, freezing that storm into the seemingly solid world we know. It's as if the universe requires a witness to become real, and by witnessing it, we hold it in place. Now, I can already hear the questions forming, and they are the right ones. The big one is, what counts as an observation? Does it require a conscious human? A cat? A camera? This is the deepest mystery, the mystical heart of the matter. The equations don't specify. They just say, measurement. Is it the interaction with a measuring device? The irreversible recording of information? Or does it, in some profound way, require a spark of awareness? Physicists debate this fiercely. The Copenhagen interpretation would say any interaction with the macroscopic world is enough. But other, more mind-bending interpretations, like those involving consciousness, open the door to a universe that is deeply participatory. What if our attention is not just a passive reception of data, but an active force in the cosmos? The Quantum Zeno Effect is a tantalizing hint that this might be true. It's a scientific validation of an ancient, mystical idea that the seer and the seen are inextricably linked, that the mind and the world are not separate. Imagine the implications. A monk in deep meditation focusing single-pointedly on a candle flame. Is he, through the sheer power of his sustained attention, stabilizing that flame at a quantum level? When you are so utterly absorbed in a task that you lose all sense of time, are you, in a way, enacting a personal Zeno effect, freezing a moment of reality through your focus? And what about the reverse, the quantum anti-Zeno effect, where frequent observation can actually speed up decay? It's like nagging a particle into changing. This paints a picture of a universe that is responsive, fluid, and deeply conversational. Our relationship with reality is not one of a master and a slave, but of a dance. A constant, subtle negotiation between possibility and actuality. Now let's project this into the future. The potential is staggering. We are already using this principle in fledgling technologies. Quantum computing. The most delicate part of a quantum computer is its qubits. They are like our spinning coin, and they desperately want to decay, to lose their magical state of superposition, a problem called decoherence. What if we could gently, constantly watch these qubits in a way that doesn't collapse them, but stabilizes them? We could use a tailored version of the Zeno effect to freeze them in their computational state, allowing us to build powerful machines that are currently just a dream. Medicine and biology. What about unstable molecules in the body? Could we design smart drugs that use a form of the Zeno effect to stabilize a beneficial molecule, making a treatment last far longer inside you? Or perhaps to destabilize a harmful one, like a cancer cell, using the anti-Zeno effect to trigger its rapid breakdown. Time and consciousness. This is the real frontier. If observation shapes reality, then what is the true nature of consciousness? Is it a mere byproduct of the brain? Or is it something more fundamental? A feature of the universe that is required to crystallize existence from a sea of potential? The Quantum Zeno Effect doesn't answer this, but it points a giant, flashing arrow at the question, demanding that we take it seriously. So, the next time you feel like the world is solid, fixed, and independent of you, Remember the spinning quantum coin. Remember that at the very root of being, there is a paradox. That to be is to be perceived. That the universe might be a story that is only being written because someone is there to read it. Your attention is not trivial. Your consciousness is not an accident. It might be one of the most fundamental, creative forces in the cosmos. You are not just living in the universe is living through you, and in some small, yet profound way. Your gaze helps to hold it all together. If this journey into the heart of quantum mystery fascinated you, if it made you see the world a little differently, then do me a favor. Give this video a thumbs up. It really helps the channel grow. And subscribe, because we have so many more cosmic secrets to explore together. I'd love to hear your thoughts in the comments below. What do you think an observation is? Do you believe our consciousness shapes reality? Let's get a conversation started. And for those of you who want to dive even deeper, to explore how these ideas connect to a grander theory of a responsive, holographic cosmos, I've written a book called Holographic Multiverse. In it, we connect the dots between quantum weirdness, consciousness, and the nature of reality itself. It's a wild ride. If you're interested, the link is in the description below. Thank you for watching, for wondering, and for being a part of this incredible participatory universe. Stay curious. See you in the next video.